Okay, so I had a request for homework problem 15.34, and I pre-wrote these wave functions out. I maybe should have written out also the probability. The question is, what's the probability that a particle in a one-dimensional box is going to be found between 0.3, how do you spell 3? 2a and 0.35a, and I forgot the a here, but I'm just going to write that down as notes. Okay, so what's the probability that the particle is going to be found in this range? So the box, again, we're looking at a particle in a box. It's a one-dimensional particle in a box, and it doesn't say ground state. Yeah, it doesn't even say ground state, but let's assume that this is that n is equal to 1. I guess we would assume that because in the wave function there's no n, so it has to be that. But recall, like, this is sort of the amplitude of the wave that we're considering, where this is 0 and this is a. This is a particle in a box. So, you know, if we're supposed to figure out the probability of this, the very first thing we ought to do is just verify that this is normalized. Is psi normalized? My guess is this is something you've done so seldom that okay, so we're wanting to normalize this function here. We want to make sure that this is normalized. Psi is equal to root 2 over a sine pi x over a, right? And just let's remember what the definition for this is. N squared of psi dx is equal to 1. This is already normalized if that's 1, right? That's the normalization factor. So let's go ahead and say that for n is equal to 1, psi was going to be, or rather the integral is going to be that, right? So if this is a true statement, then it's normalized and we can go back to our problem. It probably is, right? We just want to verify this. So there's no complex conjugate for this wave function, so we could say simply that the integral of root 2 over a sine pi x over a dx is equal to what? If it's 1, we're done. Alright, so let's go ahead and oh, this is squared. Right, so if we square this term, it just becomes 2 over a. Let's pull that out front. Sine squared pi x over a dx is equal to what? Now this is something we've done a few times in this chapter. I happen to remember that, but I certainly do not recommend that you memorize these. The integral of sine squared, let's say, of bx is equal to x over 2 minus 1 over 4b sine 2bx. Okay? That's just a definition. You're not supposed to know that. You just have to know that you've got to look it up. So that should be in your integral table or on the front of your exam or quiz. Okay, so let's go ahead and solve that. 2a then is, we'll sell that 2a out in front, right? Is equal to x over 2 minus 1 over 4b, and in this case b would be a, or rather pi over a, right? So it'd be pi over a sine of 2b, and b again is pi over a x. Okay, and that is all in our that's across the whole box, right? And remember, the box goes from 0 to a, so this is a to 0. Okay, we'll find out what that is equal to. 2 over a is equal to a over 2. Let's do this first one. Minus a over 4 pi sine 2 pi a over a, right? Minus 0 over 2 minus a over 4 pi sine 2 pi 0 over a this, of course, goes to 0. That goes to 0, so the sine of 0 is 0. So that whole term goes to 0. This ends up becoming 2 over a over 2 minus a over 4 pi sine 2 pi a over a is just 1. Okay? So this goes to 0. Remember the sine wave? Boom. There's 2 pi. So it goes to 0. This is sine x. So that goes to 0. So this goes to 2a over 2 minus 0. 2a over 2. And I think you can see that that is 1. Perfect. Bing. Okay? So, psi is normalized. Okay? We look back at the other, I think I'm not going to normalize the other one just to save time. I think you should go back and do that. Of course, that's chapter, you might be tempted to say, well, that's a chapter 13 question. Let me remind you that that 13 was really a foundational question for the rest of this block of material. So it looks like a chapter 13 question, but it's definitely fair game for our next exam. We need it. We need to be able to look at that stuff and have it make sense to you. Okay. So the question is this normalized? Yes, it's normalized. We just did that on a separate sheet of paper. Okay, so the next question is, well, we're back ready for the actual question now, right? What's the probability? So the probability is going to be 0.32a to 0.35a psi dx. That's it, right there. Okay, so let's go ahead and calculate this out. We have it on we have most of our work on a separate sheet of paper. I'm tempted to just copy it back over. This is going to be root 2 over a sine pi x over a. All of this mess squared, right? Dx is going to equal 2. But gosh, I got to admit, guys, I'm going to pull that piece of paper back out because we just did that whole thing right here. The only difference is this is where we're picking it up at, right? Where we just put a and 0 in there, but now we're going to put 0.35a and 0.32a, but it's the same thing. So, see previous interval on video. If that doesn't make sense to you, please ask me what I mean by that. And so we get that to say this is 2 over a. I'm copying this over this other sheet. X over 2 minus 1 over 4 pi over a sine 2 pi x over a. Now this is 0.35 a to 0.32a. And that's it. I mean, obviously we've got to calculate it out, but I think these a's are going to all cancel, but let's go ahead and do them. 2a x is 0.35a over 2 minus a over 4 pi sine 2 pi 0.35 a over a, right, minus 0.32a over 2 minus a over 4 pi sine 2 pi times 0.32a over a. Okay? Now these terms no longer go to 0 because we got some number in there which is messing it up. Okay, so we'll calculate each of these individually. Oh, by the way, you see that each of these has an a term in it? So that a crosses off with that one and that one. Okay? and these two a's cross off. So now we're down to some pretty simple math. This 2 is going to cross off 2. Let's get rid of that and make this a 2. And that and make this a 2. Okay, so this becomes 0.35 minus 1 over 2 pi sine 2 pi times 0.35 minus 0.32 over 2. Oops, got rid of that 2. 0.32 over 1 minus 1 over 2 pi sine 2 pi times 0.32. Okay, 0.35. I'm going to do this out one step at a time. Minus 0.32 1 over 2 pi. And we'll calculate this sign out. Okay. .35, enter, 2 enter, pi, times, sine, goes to 0.809. I'm going to verify my calculator set right real quickly just by doing 2 enter, pi, enter, times, sine. Oh, I go to 0. It doesn't. Oh, it does. Yeah. Okay. I'm going to go pi, just a second here, pi 2 divided by sine. Yeah, this is set right. Okay, so it's 0.809 and 0.32 enter 2 times sine of that is 0.905. I'm going to calculate these numbers just one more time just because it's going to be such a disaster if we find that those are wrong. Okay? 2 enter pi times 0.35 times sine. Okay. 2 enter pi. Okay, so I've checked these two numbers twice. I believe they're right. Now I'm going to take this number and divide it by 2 pi. Enter. Times divided by. This comes out to be 0.144. This number comes out to be 0.129. Okay, and so this is going to be 0.35. Just a minute here. .221. 221 minus 0.176. That's what this number is. Okay, so this comes out to be 0.0452. 0.0452. That's the probability. Okay, so what that means, of course, is 4.52% of the time the particle will be between, x will be between 0.32a and 0.35a. It'll be on that interval. Okay, hope that's helpful. I may do the separate part, the second part under separate cover. Hope that's helpful.